fire every frame that the key is held down. Then it will add to the current position the forward vector from the direction our vehicle is facing. So if our vehicle's turned, this will still make it move the direction the headlights are facing in. Times 5 is just sort of the way we're setting the speed for now, just so it's more noticeable. We'll make this number changeable here in a minute. And time delta time is necessary because the update function gets called every frame, and depending on a machine's system specs, the frame rate may be much higher or much lower. And by multiplying by the amount of time that passes between frames like this, we get a consistent speed independent of frame rate. So we're going to save the script, Control S or Command S, depending on your OS. And let's try it. Press play. And now when I press W, I can see my car is going backwards. I seem to have misunderstood the headlights. And I should have known this. You'll see here the Z-axis is pointing this direction. If you hold down Shift, you can select more than one thing at a time, or I think Control or Alt or Command or something. Okay, I'm going to rotate the headlights back in front. There we go. And now when I press play, sure enough, W drives my car forward. Let's make it so we can turn the car. We'll just write a new if statement. If input.getKey keycode.a. Then here we're going to do transform.rotate 0.0f negative 80.0f times time.delta time 0.0f semicolon. Something else I'd like to point out is that transform is implied to be the position, rotation, and scale data of the object that we've assigned the script to. So if we had a reference to some other game object, we could do that reference .transform and get the position, rotation, and scale of that object. If we don't specify a game object, then it's assumed again to be the one that we assign the script to, or in this case, car_all. We're going to copy and paste the turn code over to the D key and remove the negative. And what this is doing is it's calling a rotate function. Remember, so transform keeps track of rotation, and rotate, there's many ways we can call the rotate function. The one I'm using here, we give it the angles to turn along each axis. So we want to rotate 0 along the x-axis, 80 degrees to the left in this case with a negative, in the y-axis, which is the one that goes up and down through us, again times delta time to accommodate for variable frame rate, and 0.0f along the z-axis because we don't want to roll. If we test this now, we'll save the script, press play, and your car should now rotate and drive. There's no reverse yet. We can add that in a moment. And you can, of course, you can drive it off the edge of the world if you so please. Let's go ahead and add reverse. This will be a very simple change. We're going to duplicate the code that we have for moving forward, assign it to the S key, and we'll subtract instead of add that movement amount. And let's actually change this number also to 2 so that we will move backwards slower than we can move forward, as cars tend to do. I will say that there is a more robust way to handle input that allows the user to remap the key codes. So you could also use the arrows or use a joystick or a gamepad. That won't be covered here, but I will show that example of that in the final source code that will be provided at the end. And so again, let's save that, press play, and we can now drive the car around, including reverse, and take them off the edge of the world. You might be wondering, how do I know those things that I'm doing inside the script? How do I know that those exist? Unity actually has a great script reference, unity3d.com/support/documentation/script reference index.html. And you'll see a link to that on the site. But this provides all kinds of helpful information about what you can and can't do in script, and as well as examples that you can switch to C# or JavaScript. We just have these numbers floating around 5 and 2 and negative 80. What we're going to do is we're going to make the speed modifiable for our car. Here inside of our class for car driver in the car driver script, going to add public float forward speed equals 5.0f. I'm going to make 3 variables. Backward speed equals 2.0f. And turn rate will equal 80. So we have 3 public float variables. These f's after the 0 are to show the computer that this is a float as opposed to a double precision value. And down here we're going to replace these numbers we had with the variables, forward speed and backward speed. I'm auto-completing, by the way, by pressing enter when it suggests what it was that I was typing. Turn rate and turn rate. Okay, and so all we've done is we've made 3 public variables and replaced where they were in the code down here. Saved the script. And now if you click on Carl in the editor and scroll down in the inspector, you'll see that here these numbers are exposed. Forward speed, backward speed, and turn rate. And it inferred those names based on how I camel cased these variable names. See, I called it turn rate with a capital R, so it knew that turn rate was the word. And we can change these numbers here. So if we make the car drive forward much faster, we can change that 5 to 20. And vroom, now it's so much faster than it was previously. We want to make it move much slower, change that number, and it goes down to a crawl. And so of course this is a really powerful way to make it so you can create an object and then change it inside the editor on a per case basis. Or for example, if a programmer on your team wants to set up something without worrying about tuning, and then have a designer on the team worry about how to get the project's pieces all moving and behaving in a fair and sort of usable manner. It's an advanced and sort of future hint that we are manipulating this car's position directly by changing its transform position. Because it has a rigid body, another way that we could move the object is to apply physical forces to it. And that works a bit differently. Instead of update, we would use the function fixed update. And instead of transform position for our code, we would instead do something that looks like rigid body dot add force vector transform dot forward, and this would apply a forward force to the car of a certain magnitude. This has a certain type of gameplay that it leads to. I find it sluggish, of course, but for games that are physics based, it's important to use forces to move things around for collision reasons. Also note that I did this in fixed update. The difference between fixed update and update is that fixed update is called a known number of times every second, unlike update, which is frame rate dependent. And so it's important to use fixed update for any code that does physical manipulation to the rigid body for a vehicle or an object. We were able to use rigid body there. It's just like transform, is it implies that it's the rigid body assigned to the game object the script is for. Now let's add a sphere to make hills. Going to go to game object, create other sphere. We have a sphere here. Let's make it, let's change its size a bit. I'm going to do 0.74 to make a short flat hill. Move it down so it's halfway underground, using the F key and mouse wheel and stuff to get a close-up view of doing this. Okay, and for now let's just leave it white. Try driving over it, and you will initially encounter that it is going to flip your car. It's very, very oddly tall for how big it looks. And see, the reason for that is because by default a sphere uses spherical collision, which is why we see this big sphere around it. That's what the car is hitting, because it's a faster calculation that can do collisions based purely on distance. What we really want here, component physics mesh collider. And again, this is with a sphere, the hill selected. I'm going to go to component physics mesh collider. Tell it to replace, because it's saying you already have a sphere collider here. And now it will use the mesh data, the polygons of our shape, instead of assuming it's a sphere, for collision. And so now we have a much more modest bump for the car to ride over, and a lot more sort of smooth driving experience over the top of it. here, let's go and assign grass to the hill so it blends in a bit better. Let's create a better system for our camera. One way to do this, sort of a very easy, I might say lazy way to do it. If we just click on the vehicle and move our viewport around to where we'd like it to be for a third-person camera. And then we click on main camera and do the same trick from earlier. Our game object align with view. That'll put the camera where our view is. And remember, it'll stay there. But if we make it a child of car all, then it will move along as the car does. And we now have sort of a third-person camera. But this results in an extremely rigid camera, which isn't very nice. It's not very smooth. We don't have as much control over sort of making it lag behind the car or any effects like that. So let's move the camera back out of car all. And let's instead control the camera with a script. We'll go to Assets, Create, C# script, and we'll call this car cam. Okay, now selecting car cam, going to that script in mono. We are going to create a few new variables. Public camera, use camera, public transform, track object. And then inside the update function, we're going to tell use camera dot transform to look at track object. And now the way this is being set up, we can specify any camera to track any object, and it will constantly point itself at that object. We could have the object assume that what we've assigned it to is the camera or is the object to be tracked. Instead, we've written this in such a way you can swap them out. Partly is to show how to make those connections inside the editor through various ways. And this will also, by centralizing it in this fashion, make it easier for us to change the ways that camera can be switched between if we want to have multiple camera modes supported. So let's go back to the editor. You'll see now we have our car cam script, but it's not yet assigned to anything. It doesn't really matter what it's assigned to. Let's assign it to our car just for sanity. And now when we scroll down here, you'll see the car cam wants to know which camera should track which object. And there's two ways to do this. The one that I like is to drag here from the hierarchy main camera onto where it says use camera, and it fills in that slot with the camera information from that object. Now for track object, it wants to transform, and I could drag car all onto it. Instead, I'm going to click on this mark next to it, which gives me a list of everything that has a transform, all the things that I could have dragged onto it, and I can select car all, double click that, and it fills in with the transform of car all. And so now when I drive around, the camera is constantly following the car, which is kind of a nicer camera than either of our previous ones that we tried out. There's other ways we could control the camera to switch between camera modes. I'll include the source for that in the final version, but I'm not going to show you here. Let's add more hills though. So I'm going to duplicate the hill. Again, that's Control D. I also want to say that just like there's this green arrow we can drag up and down with, there's a green square which allows us to drag it perpendicular to that axis, which in the case of our hills is a really handy way to keep them flush with the ground while we change their dimensions. We can have some bigger hills and some smaller hills, some longer hills. Duplicate these two, rotate them. There's really no harm in them overlapping as long as it's kind of the shapes that you want. 1.5, 2, there we go. And now when I drive my car around on them, you can see it bumps around, pushes its way over a bit. Oh, the car toppled over again. And we can still drive, you know, that could be dealt with another way. But we want to give the car a way to reorient itself when it gets flipped, kind of like the Warthog from Halo. Before we do that, let's do a little bit of cleanup. We have these spheres floating around. Let's call those each hill. Actually, I'm going to select all three. Name them all hill at the same time. And we already have a ground object. Let's make them children of the ground object, just for keeping organized. There. Inside of our car driver script, we want to add a new key to reorient the car. Let's make that the X key. We know it's going to look a lot like the previous one, so we can copy and paste.